I stopped.
I am Harindra Lal, Chair of the IEEE Intersociety Activities Committee. This is our 13th program we have been running. For this program, there were 331 registrations. So almost a record for our program ever since we organized from 15th of April. It is due to the quality of the speaker who is presenting the paper here, Professor Celia Shahnaz from Bangladesh University. She is a well-known figure in IEEE. She has reached several stages in there. She will be introduced to you properly later. Some suggestions to the participants. Somebody has not put their name in the list. Their mobile's name will be coming or some other names will be coming. Please change your name to that so that we can get the name of the participants who are in the program. One more suggestion, we have introduced a feedback link in the mail sent to you. Please click the feedback link and give your feedback to the program, which will give us an encouragement to our weekly programs. Now I will move to the welcome, the speaker who is giving the welcome address. Dr. Shabarish. Shabarish has joined. Dr. Shabarish?
Yes, sir. Joined, sir.
Yeah, Shabarish, you may take over.
So, good evening, good day to all, and welcome to the 13th edition of our webinar series. As sir pointed out, extraordinary times require extraordinary technologies. So, we are now connected virtually. And I think there's an overwhelming response from across the globe for this kind of activities, which show that the quality of the webinars is quite high. And with this encouragement, we are going ahead with a lot more webinars. And I welcome all the participants. I also welcome Professor Celia Shahnaz, Bangladesh University of Engineering and Technology, who will be delivering a webinar on very important subject, that is the machine learning, deep learning, and how it can be utilized for detection of diseases, which is going to revolutionize the detection process, or maybe doctors will also soon be obsolete. So with that note, once again I welcome Professor Celia to this event. On behalf of CSI and IEEE and all other group members, I once again welcome all the participants to this webinar. Let us take this forward. Sir.
Shabrinath,
Yes.
to give you the introduction of the speaker.
Good morning, good afternoon, and good evening, ladies and gentlemen, from wherever in the world you are. It is my pleasant privilege to introduce to you Dr. Celia Shahnaz, the resource person for today's Intersociety webinar series. A short introduction on IEEE. We have around 9 societies coming together in this event. A short introduction to the non-members of IEEE here. IEEE happens to be the institution of electrical and electronics engineers, happens to be a not-for-profit organization, the largest not-for-profit organization of professional engineers worldwide. The IEEE has over 420,000 members across the world, and for its operations, IEEE is divided into 10 regions globally. of which the entire Asia Pacific falls into what we call the region 10 of the IEEE. Having said that, IEEE has multiple organizational units, Kerala section being one of those, and we have come together as part of IEEE Kerala section and of quite a few other societies here on this platform. And it is a very proud moment to let you all know that IEEE Kerala section just received the MGA Outstanding Large Section Award for its activities in 2019. Obviously, with the support and help and the unending sheer spirit of volunteering activity of senior members like Harendra Lal sir, VKD sir, and others here, and of course with young professionals and student members as well. Having said that about IEEE and IEEE Kerala section, I would like to introduce to you today's resource person, Dr. Celia Shahnaz. Dr. Shahnaz is a senior member of the IEEE. She is also a fellow of the Institute of Engineers at Bangladesh. She received her PhD from Concordia University, Canada, and is currently a professor at the Department of Electrical Engineering at the Bangladesh University of Engineering and Technology. Dr. Shahnaz has published over 120 international journal papers, is a recipient of the Canadian Commonwealth Scholarship, and also is a recipient of a gold medal for her contributions in science and technology from the Bangladesh Academy of Science. I'm also happy to let you know, ladies and gentlemen, that Dr. Celia Shahnaz is currently selected as a candidate to run for election as a candidate to the Region 10 Director-elect position for 2021-2022. The other contestants are Dr. Supavati Amravit from the University of Chulalongkorn at Bangkok, Dr. Lance Fong, Emeritus Professor at Murdoch University, Australia, and Dr. Nurulza Noor, a Professor at University Technology, Malaysia. So Dr. Shahnaz, it is over to you to deliver your talk on deep learning for biomedical applications. The entire panel is eager to listen from you and to learn from you. Welcome, ma'am.
Thank you very much for a humble introduction. Thank you, Dr. Harendra Lal sir and other volunteers of IEEE Kerala section who are working very hard for this initiative. Hope you can see my slide now, right?
Yes.
Yes, ma'am.
Okay. So it's a great honor to be here. Actually, it is one of the main focus of IEEE is that connecting others, and this Intersociety weekly webinar series is a great platform that has given me an opportunity to share my technical knowledge with a broad range of IEEE members or non-members. It's a great opportunity to inspire the non-members about the technical depth and broadness IEEE is offering by knowledge sharing. I want to thank, and let us go forward. Wait a minute, because the internet is, I'm going to the next slide, but it is taking time. Actually, what is I want to say that I'm serving in my professional life for 20 years, more than around 20 years. About this 20 years, around more than 18 years as an IEEE volunteer. But most important thing, what I like to emphasize, that it is a great opportunity for all of us to be part of at least one technical society. IEEE is offering more than 39 technical societies and councils. We can see in this program, we have EMBS, Engineering, Medicine and Biology Kerala chapter with us, along with other societies. So I am actually the founder of 4 technical society chapters in Bangladesh, Signal Processing Society chapters, Robotics and Automation Society chapters, Industrial Applications Society chapters, and Society on Social Implications on Technology chapter. Rather, apart from these 4 chapters, I deeply work in engineering, medicine, and biology, and power and energy society, because these are all interdisciplinary. Just wait a bit because my slide is not changing. Hopefully you can, I'm audible to all of you, right?
Yes.
Yes. But only thing is that slide is not moving. Okay. So this is a brief bio what Shabrinath has introduced. Actually, I like to introduce myself as a research and innovator first, because I'm an academician serving at Bangladesh University of Engineering and Technology, which is the highest ranked engineering university in the country. Apart from it, I serve in IEEE New Initiative Committee 2020 member. Since I'm the founder of site group Flash in Bangladesh section since 2013, I served in several capacities. Communications chair for IEEE Site Global Steering Committee. And in 2020, I'm serving as a chair Women Inside Working Group to inspire more women into humanitarian technology. Since I have a strong affinity to work as a research and innovator and working collaboratively with Signal Processing Society, so I'm serving as a 2022 member IEEE Signal Processing Women in Signal Processing Committee. And many of us have experience, professional experience more than 10 years, but still we are not applying for a senior membership drive. It is a great honor that I'm serving as 2020 member IEEE Global Women in Engineering Senior Member Elevation Drive. If you need any help from me, please let me know. I'm serving as Power and Energy Society Women in Power Regent and representative that has provided me a huge platform to connect with all Regent and PES members and guide them what are the benefits and opportunities as a PES member. And also as a Women in Engineering Workshop Subcommittee Chair, I really conducted more than 25 workshops in the whole world in 10 IEEE region. And it was a great honor that I served as a Region 10 WA chair in 2016. And I'm the first female chair of IEEE Bangladesh section since its inception in 1993. So this is not just a bio of myself. This is a list of commitment for me and for which I'm here today to share my knowledge. But still, I'm again emphasizing on the importance of ourselves to the involvement of technical skill development by engaging ourselves in the technical society chapters. Let me show my gratitude to Kerala section that we really work together to organize IEEE Women in Engineering workshop at IEEE Region 10 TENCON in 2017 in my capacity as chair IEEE Global Women in Engineering Workshop Subcommittee, where we have invited many women, especially founder Women in Engineering Chair of Asia Pacific, Women in Engineering Chair for India Council, where we discussed about ICT, Power and Energy Society, and different other things which reflect the competitiveness of a woman and showcasing the potential of women. And recently I was part of Women in Engineering Leadership Summit in Kerala section, where we have jointly organized a Women in Power workshop. And thanks to all contributors from younger to the seniors. It was a great opportunity to know the potential of Kerala section members, and also through my global capacity, I tried to bring opportunities to the Kerala section members so that we can work together in a broader scale. In this note, I like to congratulate Kerala section for winning 2020 IEEE MGA Outstanding Large Section Award. I really feel your joy because in 2018, IEEE Bangladesh section has won IEEE MGA Outstanding Large Section Award under my leadership. I really feel the pain, I really feel the hard work, and I really feel the joy of this achievement. So I believe in power of networking and innovative ideas, and that has helped me in doing innovative research. Quickly, I'm going to my research. Before that, I really want to know that we cannot suddenly start doing research. We really need motivation and innovative ideas and networking to explore your research, because your opportunities will be always limited, but we cannot stop. So this is a Power and Energy Society Day celebration where we made this human chain. And in the right side, there is IEEE Day celebration by Women in Engineering Affinity Group. And this is a human chain by students, young professional, seniors, past years, industry experts, entrepreneurs, who are IEEE members and non-members. Actually, this is the message I want to give everyone to you, whether you are doing a professional work, whether you are doing an industry work. While we are going for attacking or handling any problem related to research, I always try to connect with UN Sustainable Development Goals. There are 17 UN Sustainable Development Goals. Many of you know: no poverty, zero hunger, good health, well-being, quality education, and gender equality, and many others. It means our research should not focus on the privileged person like me. Rather, it should focus on the billions of people who are lying at the bottom of the pyramid. That is our goal. So I request kindly to visit my Google Scholar citations. If you look at the curve from 2013 to 2020, we are still at the middle of the year. What gives me more motivation of doing fundamental research is the curve. Is every year it is increasing, almost every year. It gives me a drive that no matter where you are, no matter how deep your limitations are, if you want, you can do a good quality research that will be cited by others, that will be resourceful to others. So that's why I have shown you the UN Sustainable Development Goals, and I have shown you the curve for the Google Scholar citation, that why I'm still driven mostly because of my research, and this curve is the main motivation for myself. When I'm today I will focus on biomedical applications. So let me share that ECG, you know, it is a cardiac signal, electrical signal of your heart. But when you are collecting it through leads, there are noises because artifacts, and because you are collecting it through leads. So denoising of ECG signals is a very important problem for many applications, because you really want to use that ECG signal for arrhythmia detection using machine learning, pattern recognition, and deep learning. I'm showing it because it is the highest cited paper for my research careers, 281 for one paper. So from 2012 to 2020, it gives hope that still people are citing it with high number, and we are in the right direction. We have chosen it, the right topic, and we are moving in the right direction. So we should do more. Today, we will focus on the biomedical signals or biomedical image signals, how then they can be handled for disease detection using emerging technology like deep neural network. So we will handle the musculoskeletal radiographs for abnormality detection from those radiographs, and among different deep learning techniques, we will be focusing on capsule network that along with my student we have developed. So of course, there will be outline. We will propose the CAPSNet model. We will justify with experimental results, and we will find the discussion with our results that why we have done this and why it is acceptable and why it can inspire many others. So the motivation of this work is 1.7 billion people have musculoskeletal abnormalities, but our doctors are doing it subjectively using the subjective evaluation only. So we wanted to automate this process to accelerate the diagnosis. So also there are a lot of deep neural networks such as convolutional neural network that has a lot of shortcomings, and that is why we wanted to investigate the capability of CAPSNet in detecting musculoskeletal abnormality. So before telling the good features of CAPSNet, let us know what are the limitations of CNN. CNN has poor translational invariance and lack of information about orientation. And also CNNs have trouble when subjects are rotated and when lighting conditions are changed. So, and also CNN needs huge data set for training. But you know, it is not always possible to have a huge data set publicly available. So that's why we have proposed CAPSNet for musculoskeletal abnormality detection, and how it overcome the problems in CNN. We need to know it. Output from each neuron is replaced by a vector. That is important. And max pooling operation is replaced by an effective routing by agreement algorithm. An output vector of a capsule represents the probability that entity represented by the capsule is present in the current input. And mother capsule gets input from child capsule without losing the spatial information. Output node with the highest vector length gets activated. It's important. It's not the value is activated. Output node with highest vector length gets activated. And class capsule determines the correct output level. So the level is represented by a class, not by a value. So this is an overall schematic diagram that will take the input, we'll do some pre-processing, and there will be some convolutional network. Of course, there will be a primary capsule. Then we will do the optimization, and class capsule will give us the output. Another version, let us go that why we have done pre-processing and what is the justification. You know, our data set that we have used has image of variable sizes. We have investigated resizing of those images into 64 cross 64, 128 cross 128, and 224 cross 224. So if you can see the results, you know, this is an image when reshaped into 64 cross 64, 128 cross 128, and 224 cross 224. If we just move to the next slide where you will see the real musculoskeletal or the real images, you can see the image A is 64 cross 64. It is a blurred, and then 120 to 120 a little bit improved, but 224 plus 224 is better. Features are more included in C. So downsampling actually degrades the image quality, as we have seen 64 cross 64. So that's why we want to include more feature. That's why we have chosen 224 cross 224 rather than this subjective evaluation. We really wanted to rationalize our decision by objective measurements such as accuracy. You can see training accuracy and validation accuracy for different image size. You can see when it is 2 to 4 cross 2 to 4, the training accuracy and validation accuracy are higher. And not only the accuracy, there are two score. One is blind image spatial quality evaluator, BRISC score, and another is naturalness image quality evaluator, NIC score. Lower the BRIC and NIC score, better the feature preserved after resizing. If you can see, when it is 2 to 4 cross 2 to 4, both BIC score and NIC score are comparatively lower. That justifies that why we are going for 2 to 4 cross 2 to 4. This is a guideline for the young researchers. Before claiming anything, also please try to give rationale behind it. This is a proposed structure of the capsule. Convolution 1 has 256 9 cross 9 convolutional kernels, and convolutional capsule layer has 32 channels of convolutional 8-2 capsules, and class capsule includes 2 capsules, and each capsule has a dimension 2. And this is the structure. You can get it more vivid, that you are starting with the pre-processed image 2 to 4 cross 2 to 4, then the first convolution, and then the second convolution, and then you apply routing by agreement algorithm. Then you reach to class capsule, where you will determine whether it is normal or abnormal. So this is the overall proposed structure of capsule. And let me know, it is very important for the young researcher to know, we have to use a very important data set where labeling is there, ground reference is there. You know, you cannot make ground reference by yourself, and you cannot use the method by yourself. So that means ground reference must be neutral. This Mura dataset contains 14,656 images, and among them 8,941 images are normal, 715 images are abnormal. This data is very important to know whether there is an imbalance in data. We can see the balance between normal and abnormal data exists, okay? And now, very important that how and why we have applied routing by agreement. It is an iterative process where routing algorithm acts like an orientation popularity filter. Input from lower level capsule will send to the higher level capsule that agrees with its input. This is very important. So we have plotted the training and validation accuracy. Training is black, validation is red, and we have plotted it for humerus, finger, elbow, hand, forearm, shoulder, and wrist. And we can see if we increase the number of routing as seen in the x-axis, we can see the accuracy increases. But there are two cases like E and F, where we can see if we try to increase the routing more than 4, there is a overfitting happens. To avoid overfitting, considering all types of images in the database, we have decided to take 4 routing algorithm. Okay, so now it is our time to really tell you that whether the capsule network is effective for musculoskeletal abnormality detection. It is very important. We cannot just abnormally, randomly make a choice of different algorithms, different networks. We have to justify it. So if we see the kappa, Cohen-Kappa statistical score, and that is actually more robust in healthcare studies. It measures inter-rater agreement for qualitative or categorical items. If you see different images and their kappa score for the Mura data set using DenseNet, which we are not using, but we have tested it, it is 70.5%. Whereas the capacitatic score for the same Mura data set using our proposed CapsNet is 80.115%. It shows that we have proposed a more effective network compared to DenseNet. And we have also shown it here. The green is CapsNet and blue is DenseNet. X-axis is the type of images, and we want to claim the proposed CapsNet architecture provides almost 10% better kappa score than the 169 layers of DenseNet while using 50% less training data. That means we are able to overcome the problem of need of huge training data because we are using 50% less training data. This is an important claim. And let us analyze the result. For our result, we have compared our method with another state-of-the-art work that have used the same Mura data set. If you see the training accuracy and testing accuracy for different type of images, and after observing it, if you move to the next page to see the accuracy for our proposed CapsNet using the routing in Mura dataset, you can see both training and testing accuracy increases in our proposed CapsNet. And this is also a very important claim. Rather than accuracy, we have to really know the loss of the network. The red one is the accuracy of the CapsNet, and the black one is the loss of the CapsNet, and blue one is the accuracy of the DenseNet, and purple one is the loss of the DenseNet. If we see this for different iterations in the x-axis, and if you see this for different images where we have plotted, we can see that our CapsNet is capable of producing higher accuracy and lower loss compared to the DenseNet. That accuracy is also low compared to CapsNet, but loss is high compared to CapsNet in case of DenseNet. This is a very important claim to prove, to justify that you are proposing a network, and the network is more effective for musculoskeletal radiograph abnormality detection because it is providing less loss and more accuracy. So this is the outcome. For the younger generation, I must tell you that every research should have an outcome. It has to create impact on the people. At the same time, it should have some visible result or index. This is a work of 3 generations. Myself, my PhD supervisor, one of them is fellow of IEEE, and another is a very young fellow, an undergraduate thesis student, and it is published in IEEE Access, impact factor more than 4. So it is a good effort, I should say, by an undergraduate thesis student, no matter what. So this is an indication that if you want how you can produce a quality work. It is published in 2019. Now we are using this capsule network in the X-ray images, in the CT images um, of COVID-19 patients, so that we can find whether it is COVID or non-COVID. So there are a lot of scope that I'm sharing with you. So different networks you can employ during COVID-19 also, although you will have limited data, but to increase data, you can apply data augmentation technique. So I'll tell you later. So another work, since Bangladesh membership has been grown and we have 51 student branches compared to 2014 where there are less than 9 student branches. In 14 to 20, there are 51 student branches, and I had the opportunity to travel different parts of the country and see the rural areas, how our women and children, the most vulnerable group, are suffering from skin cancer, but they are not at all aware, and they don't feel they need to treat it. And also our doctors, they always depend on the visual observation of the skin. But what I thought along with my students, why don't you take the image of those skin diseases and provide a faster computation using faster decision using deep learning technique, using computational facilities, so that our doctors can take decision very fast and accurate, thus find an easy way to guide this vulnerable community so that their skin cancer can be treated if early detected. So this is the data visualization we are using. You are using HAM 1000 data set. You can see the class name. You can see there are 7 classes. We are handling a problem that is not 2 class like the previous work. That was 2 class, abnormal or normal, but now it is more difficult problem. We are handling 7 class problem like dermatofibrosis, vascular leso, and you can see from the data, there's a kind of imbalance because melanoma is the highest. Number of images for melanoma is highest. So here in the last research, the data imbalance ratio was less, but here the data imbalance is high. So to overcome this problem, one of the solutions that I have also mentioned, if you want to work with COVID-19 X-ray and CT images that use this augmentation library, the type of augmentation we have employed, zoom, flip, left, right, flip, top, bottom, rotate, random distribution, skew with different probabilities. Okay, and after data augmentation, this is our transfer learning process. We take the image input, we do the convolution base for feature extraction, then we use the classifier for classification and find the result, that what type of image it is. So what type of cancer it is, but there should be a fine tuning strategy because there is always a debate on the number of data available for you. Strategy 1 is train the entire model. Strategy 2, train some layers and leave the other layers frozen. Frozen layers are shown by white colors. And strategy 3 is freeze the convolutional base, the whole base, and train the rest. So this is the fine tuning 3 strategies, but it depends on the available data set. If your data set is large, but different from the pre-trained models data set, of course, we should move to the first quadrant. That means we should train the entire model. If the data set is large, but similar to the pre-trained models data set, then we should move to the quadrant 2, train some layers and leave others frozen. If there are small data set and different from the pre-trained models data set, then we will train some layers and leave others frozen. And if small data set and similar to the pre-trained models data set, that we will keep and freeze the convolutional base. This is actually insight and study and survey analysis that will help our young researchers to handle the variation of the data set, at the same time variation of data. So there are a lot of conventional features which not necessarily were applied to the skin cancer images. So we have also implemented the conventional features. I will tell you what. And we have also tried to find the efficacy of the different models like Inception V3, VGG16, VGG19, ResNet 50. So, and this is a typical model architectures. Color shows the yellow shows the convolution layer, blue was the average pool, and green was the max pool, red one the concatenation, and the purple is dropout layer, and pink is fully connected layer, and the purple is soft mix. There are different operations just for our kind understanding. And this is a Inception V3 model where you can see the input and you can see what output we can get in a theoretical way. Okay, so the top layer specification that we have adopted for all models, that is our classifier, is the global average pool layer, dropout layer, batch normalization layer, and dense layer. We didn't use all. So for top layer specification for all models, we have used this layers only. And what are the conventional features? This is very important for me because the skin images are color images, color features. So we have used color features available in the literature, and also we have used some features such like image quality measure. And since it is in the color domain, and there are a lot of domain like red, green, blue, hue, saturation, YCBCR. So we have done the histogram analysis in these color planes. And this we have combined all these features, color features, image quality features, and histogram based features in different color planes. You can see the accuracy. This is an interesting node, and that gives, sometimes you can say if you apply deep neural network, your result will be high, but it has to be justified. That's why conventional compared to the conventional features, we can find that when you're using deep neural network models, the accuracy is really found higher. This is a validation and investigation of different models when applied to skin cancer and disease detection. And from this result, what we are doing, actually we can find that top stages with more images trained on deep neural network are acquiring better accuracy than the classical model. That means different networks work better for different stages. That means we really don't need to take all stages. So we have to find the best stage, and then we can propose an ensemble method where we will take best stage decision of different stages of different models. So our future proposal on which we already worked, and now I have finished to work along with my students on tuberculosis detection, where apart from the skin cancer, also we are working on tuberculosis detection, where we have employed this strategy that we will do some pre-processing, then we will have fusion of layers to find the features, and then we'll send them to classifier for prediction. Since the skin disease data set is huge, and we are collecting more data before the lockdown from the local community, from the hospitals. So we are still undergoing that work, but for tuberculosis data, we have seen that if you do the fusion of layers and then we send them in the classifiers, then it gives better result. And it gives us a hope that when we will complete this algorithm for our skin disease data set, this is expected that it will give better result. So let me give an opportunity to guide the young one that how you can learn this based on by organizing this event. Last year, I led Signal Processing Winter School 2019. How we did it? We applied to the IEEE Signal Processing Global Membership Committee for a fund, and we got $5,000 fund. And this is a very good initiative. You can bring foreign expert to train you about your deep learning and other techniques. And we had speakers from Malaysia, India, USA, Uruguay, Bangladesh. And another way, I was the founder of IEEE Speaks Con. This is a collaboration. I'm really liking what Kerala section is doing. This is a collaboration between section and SPS chapter, and we really founded this conference. I had a dream to take this second version to other section, because I was the founder of Women in Engineering Conference, which was started and founded in Dhaka in 2015. But after that, for last 5 years, we are collaborating with different section. So let me give an opportunity to tell this, that we can take it, do it collaboratively with Keller section or any section in region 10. Also, this is related to today's work. Also, signal processing is related to today's. So IEEE BASITCon. I was the founder of this. This is a collaboration between section and EMBS chapter. As a young chapter, actually, founding a conference to bring together all researchers in home and abroad. It was a commendable initiative, and we really wanted to train our people to know about the implications of AI, ethics of applying AI. That's why under SSIT, we have done this workshop. So this is actually, you know better than me, you have many experienced volunteer, but you know how this single webinar or single seminar cannot make a huge research community, but we have a lot of talented volunteers in Kerala. Let us do the next version in a collaborative manner. If you want, I will be with you, so that we can do collaboratively, and most important, to bring industry in our technical society chapters, because we really need to know the industry needs. And also for women to women empowerment challenge, we have guided them to apply deep learning, machine learning techniques, and find solutions to develop different apps, so that like that skin disease, if it is developed as an apps, then community clinic will be enough. We don't need to come to the town. So a women in hill tax area, it will be sufficient if he or she comes to the community clinic and using the, or anybody can use the apps, send the data through the apps to the doctors, and doctor can make a diagnosis. So this type of solution our women has provided through that, where they have utilized the knowledge of deep learning and machine learning. So let me share that because of our hard work, our research, our technical contributions for improving the technical skill, in 2020, we have IEEE EMBS Bangladesh chapter has received 2020 IEEE EMBS Regional Outstanding Chapter Award. I'm serving as a chair this year. It is a huge hard work for the volunteers from the very beginning. So this is some of my awards. 2013 Women in Engineering Professional Volunteer Award. From the very beginning, my first event was research paper presentation by women in engineers, where 21 universities participated. It was in 2011. 2015 Women in Engineering Inspiring Member Award from the Global Women in Engineering. 2016 MGA Leadership Award. And since I have a strong affinity for humanitarian technology, 2019 Region 10 Humanitarian Activities Outstanding Volunteer Award. You know, this is not a list. This is a more commitment to do more research, whether you are doing women in engineering, whether you are doing young professional, or whether you are doing society activities. So this is actually group our Women in Engineering group that became the best in the region, best in the world, and our Women in Engineering student branch, for which I am the advisor, best in region 10 and best in globe. But majority of the work was the technical events apart from the professional event, because ultimately we have to survive as a technical expert. People will be calling us as a technical expert. Sharing of knowledge is very important. So I had the opportunity to take this 25-year celebration banner from Region 10 Director, Prof. Cookzin, and it gave me more drive, and we really worked more hard in the technical side, like founding new conferences with the society chapters, doing the industrial DL lectures, doing the winter school, and that actually helped us to gain 2018 IEEE Outstanding Large Section Award. And it is a great honor to receive the awards for my students, for my young professional, for WA student branch, whom I have mentored from starting from the idea generation to the implementation. It is a great honor to receive it from IEEE President, future President, IEEE Regent and Director, and future Director. Hope it has given me more courage, and I have faced the highest challenge of my professional life. IEEE TENCON 2020, a Region 10 flagship conference. It was during the pandemic, although we got highest number of response compared to the previous TENCON, more than 1,000 papers. But in the pandemic, we did it in a completely virtual mode. Thanks to Kerala section, many members have supported us. And this is the first Region 10 flagship conference. It is not a history for Bangladesh also, it's a history for whole Region 10. Hope it will give courage and strength to many others who are preparing to disseminate this timely delivery of research outcome of so many authors. And to train others, immediately I felt obligation to arrange this virtual conference organizers panel to explore challenges of organizing a full virtual technical conference to the Region 10 members. It was a commitment for me that what was challenging as about to cancel, we did it, and it is then important for us to share this knowledge to all of you. I really thank who participated it and who really are now looking for that how to make a successful full virtual technical conference, where we have involved many technical society chapters as Kerala section is doing. This is a very commendable initiative by Kerala chapters. I'm just showing this just to share that similarity of our thinking in promoting technical knowledge and research collaboration. And for sure, this TENCIM and virtual conference organizers panel has created more opportunity among the participants for empowering them through collaboration and research activity. So thank you for your patience, and I tried to give a brief overview of the research contribution on the title and also the related outcome in terms of papers and in terms of activities. It is very important. I may be a good researcher, you can be a famous researcher, but your research should be shared by others, and we should have a commitment to provide our time, talent, and treasure for improvement of the technical society around us. It is our duty, it is our responsibility. I tried my level best to do it within the limited capacity. But I must say that capacity is not an issue, country is not an issue, state is not an issue. If you have a drive and motivation, we can do anything, and we can prepare ourselves as the most competitive one so that we can tackle the challenge for the smart world. And I want to mention the please contact and visit my website www.celiashahnaz.com so that you can let me know how I can help you to progress your research. Thank you very much.
Thank you, Professor Celia. There are one or two questions. What was the role and contribution of AI in the study presented?
Can you just repeat the question?
What was the role and contribution of AI in the study presented?
Okay, because actually you see the whole, in the whole application, musculoskeletal image detection, radio abnormality detection. So actually if you wanted to find out the features like image quality features, and then not necessarily your accuracy would have been very high, but we have applied we could apply artificial neural network, but we have given a better version like CapsNet, a deep neural network, so that we can get a better accuracy. So the role of applying AI here is to have a better accuracy, provided we have a fastest computational facility that will help the doctors. Otherwise, you know, our doctors, the number of the expert doctors is always less compared to the number of patients. So if our doctors duration of handling a patient is 12 hours per day, and at the end of the day some patient comes, from the visual observation of the radiographs, it is sometimes very difficult, and doctors may lead to the wrong decision, and even if he or she is an expert, to help them this automatic system, and that will give a better and accurate decision, will emphasize the doctor's subjective decision. So that's why we are transforming the whole image data into number of values or a vector, decision vectors. So it is a huge data reduction. At the same time, is huge help for the decision-making process, which is less time consuming. At the same time, it is accurate. Thank you.
A question from Professor Sunita. How did you collect the data set for your research?
Okay. So many of the cases, the databases, if you search different university, right, Rensselaer Polytechnic Institute in New York, and also if you search for Rice University in Texas or MIT in Boston, you can see there are a lot of databases there. There are publicly available databases, but apart from it, you can collaborate with your local hospitals, and with the permission of the head of the department of the local hospital, you can also collect local data. So apart from the standard data that are available in the website, you just search, you have to search. That's why I am referring my Google Scholar citations. So if you want to do research in my domain, in my paper, the database address is given. So you can access the data. The suitability and the advantage of using publicly available data is that they are already labeled. That means somebody, some neutral body has already labeled that data, okay, whether it is normal or abnormal. And when you will collect your own data, there will be a first question that whether your data is neutrally labeled. If you label your data, I have already told during my lecture, and then if again you apply your algorithm, there is a huge chance of being biased. Okay, that's why it is important for all of us that while even if we are collecting our local data, we must get it labeled by a neutral radiographs, radiologist who is not part of our research group. These are the important things we have to always consider. about the data collection, that database must have a benchmark data, and when we will have a locally labeled data, the labeling must be done by a neutral body. Thank you.
She's asking whether you can share the data set.
Of course, I can give you the link. I will give you my paper link. If you go my Google Scholar citation and you search this title, then you will get my PDF. In the PDF, inside the PDF, the database address is there. All very open source.
There's another question from Sabina. Please explain how fusion of layers is done.
Okay, fusion of layers is that you see there are different layers, right? And different layers you are getting different features, and also from different you can combine those features, or you can combine the decisions, okay, probabilities. So both the way you can do the decision. Rather than taking a decision from one network, you can find that which layer is giving more probability and which is giving more better features. So you can take that layer from one network and the best layer from the other network, then you can fusion those decisions in a vectors before sending it to the classifier. Of course, it gives a better result. As I have received the better result for the tuberculosis data, tuberculosis detection from the image, I told you. And since we are still in the process of collecting the local data from the skin disease, we are yet to perform the analysis for cancer. But I'm sure that fusion of data in the feature level, fusion of the data in the decision level, both the cases you can get the best result, better result, rather than if you just depend on a single network. Thank you.
Another question from N. Ravindranath. Deep learning of disease detection opportunities are given biomedical engineering students doing PG program?
Yes, of course. Although it is done by my undergrad thesis student, that means he has done it early. But you know, because of this thesis work, he has been offered many good masters and PhD admission, even PhD admissions from United States, Canada. For PhD study. Of course, this is an emerging technology, and you know, deep neural network, not only for biomedical signals, I apply it for speech enhancement, for helping the hearing impaired people. And also you can apply for image activity detection, human activity detection for surveillance. And also you can apply for videos, for audio visual emotion recognition, because it is very important, because people are using speech recognition, but if you apply it for emotion recognition, then it will be very helpful for you to develop many supporting online system, because many people, students are in stress because of bad result, so they cannot share it with anyone. So in the telephone, if they want to use any counseling system, then there should be an audio visual emotion recognition to understand the counselor that what level of depression that person is having, so that he or she can, counselor can give better diagnosis. So deep learning has a many more application. I also apply deep learning for power signals. You will be knowing that if you record an audio signal, and then in that audio signal, in which grid you belong to, that signature always remains. So if you want to use it for surveillance, then, and you want to find out for criminal identification, that audio data the person has given, he or she belongs to which country, which power grid, you can find by applying deep learning. So deep learning has a huge application. It's not only signal processing, medicine, it has a lot of industrial application, it has robotics application where I am applying, and most important, it has power and energy. society has a huge opportunity to apply it. So of course, it will open up many new opportunities for the postgraduate study.
So Sunita wants to know about the best tools that you use for your experience.
Will repeat it?
What are the best tools that you used based on your experience? What
Tools.
are
There
the
are different
best tools?
tools.
Yeah.
And there are different tools. There are Python and the other things. And previously, when we did feature-based artificial intelligence, we had to use the MATLAB. Now we are using Python, and also we are actually using fast computing machine that is called GPU.
Many people have applauded your research work and your presentations and your works done in the IEEE field, both in Bangladesh and globally. And I also want to congratulate you for work. Now I will move to the next part of the program. Vote of thanks by yes, Suhair. Suhair.
Good evening, everybody. Vote of thanks is always a pleasant job. But where to begin with this question that intrigues me. As you all know, this program is a continuation of the Wednesday meeting that used to take place in the Institution of Engineers Kerala Center before this lockdown. Now 7 professional organizations rallies behind organizing this event, and our deepest appreciation to all of them. IEEE, Institution of Engineers Kerala Center, Computer Society of India, Internet Society, Project Management Institute, EMBS of IEEE, Vakkom Moulavi Foundation Trust. They are all behind it and efficiently coordinated by A.G. Harinderlal to make it a very popular event in these days of lockdown and other difficulties. He's very well coordinating the partner organizations and organizing the eminent speakers. It's a great job. As you know, it has a global reach now. Now for this event itself, more than 320 people registered. That shows a response, interest in this kind of events. And we had technology leaders to start with, Professor V.K. Damodaran, Somnath, Director of VSSC, eminent economist from the UNDP, World Bank, environmentalists, software specialists, management experts, educationalists, then an array of people, and yet more to come, very eminent people. So really, this has been a wonderful platform. And today we are very lucky to have Professor Celia to talk to us on an interdisciplinary topic of great significance. Deep learning. I'm hearing for the first time. I heard of machine learning, but not deep learning. Now I understand deep learning is part of machine learning. And this is in the medicine is one of the most rapidly developing field of science. We know that today the devices intended for medical imaging has extended image and signal analysis model, which can use deep learning for early detection of diseases and diagnosis and find solutions for that. We know that very often the diseases are detected lately and the treatments are not very effective. So this is an area which is of great significance in the days to come. In one of the previous meetings, Engineer Nagesh narrated the story of a rocket engineer and a gastroenterologist traveling together. They were casually talking, and finally that resulted in capsule, camera, and endoscopy. So the combination of doctors and engineers make these areas very, very fruitful and rich. Okay. I also remember Professor Valithan talking in one of his meetings. He came from America with a social purpose. The purpose was that the rural women had rheumatic valve problem, working women. So they are all suffering for their earnings. And a rheumatic heart valve was the problem. Damage to the valve was a common problem. And he wanted to find some solution, and he thought IIT will be the best place to do the research. And he came to IIT and discussed the problem with the professors there. They felt making a valve in IIT is not a very dignified thing, and it's only a workshop job, something like that. So they will be doing a infinite element analysis that will make a model of heart and all that, but it's of no value, no applications. You might have heard Professor Celia talking about 1.7 billion people suffering from musculoskeletal abnormalities. So you find a solution for them, detection of the diseases, that makes a big change in the social life. So that's the real purpose, that the engineers should enter into society, what people are needing, what people are wanting, how people are suffering. And if you can find solutions, that will be great. So that's her last slide showing, I changed the world, I'm an engineer. So the mission of an engineer should always sound foremost, that your job is to transform the world, change the world. So you have to be observant. Observation is very important. Look around, find problems. Professor Celia is a very active, extraordinary IEEE volunteer. And she has taken initiatives all over the world to make, to bring in changes. That's very important. And she goes in letter and spirit to the IEEE tagline, technology for humanity, advancing technology for humanity. So this should be the motto of all professionals. And while we are working, we need to develop technology that is useful for the humanity. I've seen her in many forums. In the last 2 months, she has appeared 3 times in Kerala forums, WIE, PES, and many other student activities. She's a very good motivator, and she's inspiring youngsters and students and women to join the professional cadre and bring in this desired change. So she's not only a friend of Kerala, but I think she's also a close relative of Kerala. And she's a candidate for the Region 10 Director. As Region 10 Director is a post where you can do much larger things for the professionals. And I think we all should support her candidature and ensure that we have a place in the Region 10 as our representative, Celia. So I wish you all the best in your professional career and your teaching career and your volunteerism, which inspires all of us. We are really thankful to you for accepting our invitation, and we look forward to your continued friendship and patronage for building professional organizations in the state, and also identifying topics that are of importance to society. And we wish you all the best in the days to come. I should also thank Shankar and team for very well supporting the online platform, and our leaders, Shabri and other organization leaders. This are to be complimented for organizing excellent talks that might lead to changes in the society in the days to come. Thank you all.
Thank you. Thank you very much.
Yeah, next week we have How to Coexist with COVID-19 by Dr. Binoy S. Babu, Epidemic Intelligence Science Officer, National Center for Disease Control, Delhi. Another very interesting topic and very relevant topic for the day. Expecting everyone to participate in the program. Thank you very much. And wish you all the best.
I thank Harendra Lal sir, Suhair sir, my friends, Shabrina, and others, especially the participants. We can always join and arrange the program, but if the participants are not there and if the knowledge cannot be shared, there is no impact. So I actually thank the participants and hope we'll have more collaboration and more webinars, although the lockdown has put many limitations on us, but I can see it has created more opportunity to connect beyond the borders, because it was travel previously, but there is no travel. So we can reach out to more members, unknown members. I think it is a blessing in terms of knowledge sharing. So I thank the participants and all the organizings for inviting me. Thank you very much. And I wish you all the best for your future endeavors.
Thank you, Professor Celia. Good night to you. See you next time.